So today we're going to be doing 2.2a, which is limits involving infinity. And today specifically, we are doing horizontal asymptotes. So something that I want to address right up front about horizontal asymptotes, because you haven't taken a class like this, is we can cross horizontal and oblique, which we'll talk about tomorrow, asymptotes. The only asymptotes that a function cannot cross are vertical. Vertical are absolute. You cannot cross a vertical asymptote. But you are going to see where we cross horizontal asymptotes. So I just want to make sure that you're aware that that can happen. It's just a trend or a line at which your function curves near, okay, and approaches. It doesn't necessarily mean the function doesn't cross it. All right, so let's talk a little bit about end behavior. You should all be familiar with end behavior. We hit it really hard in Algebra 2, and I'm sure you talk about it in your other classes as well. Basically, as this graph approaches negative infinity on the x, what happens to the function? It gets closer and closer to the y value of 0, right? Which means that on both sides, the x-axis acts as a horizontal asymptote. See how the function gets closer and closer to the x-axis. What's the way we can say the x-axis in the form of a line? Y equals 0. Same thing as the x-axis. All right. So this little chart here helps us determine end behavior of polynomials. I want to just put it out there that polynomial functions do not have horizontal asymptotes. We are going to deal with some that do, but first we can determine basically functions going to infinity with polynomial functions based on their end behavior. So if a polynomial function has a positive leading coefficient and an even degree, that means that both sides go upward to positive infinity. If you have an even degree but the leading coefficient is negative, it goes down on both sides to negative infinity. Now the odd degree are where opposite sides are different. The way that I always recommend remembering this is anything that has a positive leading coefficient will always end upward. Anything odd will always be opposite on both sides, even will always be the same. So that's the way I remember it, because this chart will not be provided for you on a test or quiz. You do have to know these, be able to do it by memory, okay? So as you can see, odd degree, it starts, as we go to negative infinity on the x, we go down to negative infinity. As we go toward the positive infinity direction on x, our function goes up. And then negative is the exact opposite, okay? So we can use this information to help us determine the following limits. All right, so I'm going to zoom in here on the example so you can see it a little better as I go through it. So first thing we want to look at is this polynomial that we're taking the limit of in standard form? No, because it's not in descending degree order, right? So what do I need to rearrange to get this into standard form? Good, this has to be up front, and whatever coefficient it has, it's going to maintain, like this. So now we can determine our leading term. It tells us what the degree of the function is. In this case, what is the degree here? 4. Good, so it's an even degree with a, what kind of leading coefficient? So this is even negative. So even negative, both sides go downward, right? So no matter what side we're looking at the negative infinity side, it's going down to negative infinity, okay? All right, next one that we're gonna look at right here. It's already in standard form, as you can see. What is the degree here? Odd or even? Good, the leading degree is odd, and my coefficient is positive or negative? So it's odd positive, which means we start down and we end up, right? So if we're approaching the positive infinity direction, we're going to be looking at what it's doing on the right, which is going up to positive infinity. So that is how you determine end behavior for polynomial functions. I would expect you to be able to determine the limits going to infinity without graphing software for these, okay? So you will not be provided a graphing calculator on questions like this. You should be able to do it without one, just knowing the rules of end behavior. Now the next two questions, at least as of right now, especially this question, you will not be expected to do this without graphing software. There may be a time where we get to where you will, not this one, but other ones, but right now, you have to use graphing software. So we cannot tell what it's doing as it goes to positive and negative infinity just by looking at this. We can't plug that into a function like we can with like if it's like a 2 or a 3. So we have to look at the graph. So I already pre-graphed this somewhere. There it is. So it looks something like this. So the first thing you want to, first thing you want to determine is what the horizontal asymptote is. So you can tell where the horizontal asymptote is by looking at where the graph starts to slow down and get closer and closer to a certain line. So does everybody see it gets closer and closer to what y value? If I put that on my graph, you can kind of see where it's approaching. Now, notice that the horizontal asymptote goes through the function, which is okay, because it's a horizontal asymptote. They can go through the function. But do you see how we approach that horizontal asymptote on both sides? So, as our function goes to negative infinity, it approaches what y value? Good, and it goes to positive infinity, also approaches. Good. So we're going to sketch this, and we're going to write our horizontal asymptote, which is y equals 2. Here it is. Okay. So I'm going to draw it for you. Hang on. How I would draw it. So I know that it's at about 2 right here. And we have our horizontal asymptote. And then my graph curves around that like this. So it looks something like this. So your sketch doesn't have to be perfect. Just make sure you get the general idea of what it looks like. Make sure it looks like it's approaching the asymptote on both sides. That's important for your sketch. Any questions about that? All right, we're going to do one more sketch, and then you're going to have time to work on your assignment. So, on this one here, we have 3x. Okay, this is not functioning. There we go. 3x divided by x squared plus 1, or plus 2. So if I graph it, it's going to look something like this. Now this one you'll actually learn how to do without graphing software tomorrow, but for today, as we zoom out, it gets closer and closer to what y value? Y equals 0, which is the x-axis. So we're going to go ahead and plot that. So it's going to look something like this, where this is my horizontal asymptote, and it approaches 0 when we go to the left and to the right. So does everybody understand why we approach 0 on both sides visually? All right, that's pretty much it. As for your homework, I just want to make sure you're clear with this.